good afternoon or good morning to everybody. Um, as Daniel said, I started Value Form in 2004 as a technology company, and I was driven by the fact that the aim should be to replace plastic. And in 2004, McDonald's were using polystyrene for their burger boxes. And that was my driving point. And I looked at waste materials, agricultural materials that could be used to replace those. So that started my journey and my work with Reading University, and we had a granted patent at the time for making use of banana stems um, for making packaging containers to replace burger boxes. We went as far as making prototypes with that because it was a groundbreaking material. It was basically taking dried thermoform banana stems, taking banana stems, drying them, flattening them, moistening them, and thermoforming them to shape. Very small cottage industry type of process, but it it opened up doors to thinking along those lines. So from then on, we went on to what other materials could be there that could be used for packaging, and we thought maybe the post-harvest straws were a good source of materials. So over the last 5, 6 years, I have been working with cereal straws in principle, and lately with switchgrass and miscanthus. The cereal straws, we registered a fair bit of success in taking up products right through to the retail market in UK. And we also developed a medical disposable product from it, which are the single-use vomit bowls and bedpans and kidney trays that are used in hospitals. That was with a mixture of straw and paper. So just to illustrate a product from start to finish, I'm going to show you this product. Um, this is a base of a pizza. So normally a pizza is packed on the top surface and then shrink wrapped. This to date was being done in UK using polystyrene, and polystyrene, as you know, goes to landfill. So the retailer said, we want a biodegradable and compostable material. So we chose a rice straw, and we managed to we have a recipe that we developed after a fair bit of research to pulp the rice straw and pulp mold this to shape. Now, the requirements were quite tall in terms of biodegradability and compostability of post-use of these discs was very important. So we could meet that because it was a natural material. The other thing was it was annually renewable. So it is better than paper, because for paper, you have to grow a tree, you have to chop it, you have to make pulp, and it takes many years to grow. And there are harsh chemicals used in the pulping process, etc. And paper, once you make it, will last a lot longer than it is necessary. So paper, we are better than paper because we are using post-harvest straw. The crop is taken away. It is surplus material. It is biodegradable. It is compostable. And post-use, it can be destroyed within 6 months. You put it back in the soil. It's a circular economy solution. Now, that side is very good, but the tall order was making sure that it meets the total life cycle of the packaging during, from putting the pizza on it in the factory, then storing it, transporting it, again, packaging it for selling it on the shelves. So the temperatures were all different, and it need to be suitable for food contact. Now, when it comes to biomaterials, such a straw, um, there are standards for food safety for plastics normally, and everything is based around that. As far as biodegradability is concerned, there are standards for that as well. So there is the German standard EN 13432. We could comply with that. That was not an issue. So we had to prove that there is nothing hazardous and there are no unintended substances getting into the pizzas as a result of use of our packaging. And I think we had to go through the analysis of providing information on there are no heavy metals in this, which was obvious. Um, the difficulty was on pesticides. So we had to perform pesticide residue tests to make sure that in the packaging material, in the pulp that we make, there are no pesticide residues, and there are tests to be performed for that. Then it came to sprays. Some of the crops they use, the farmers here use growth inhibiting chemicals, and we had to make sure that the growth inhibiting chemicals are also, the traces of that are well beyond the limits so that it is safe. And the very last one was very difficult to prove, and we spent a fair bit of time thinking about it as how do we satisfy that. There should not be any dead insects in the in the packaging, because it is a biomaterial. It could be, there's something traces of that left in there, and if people are allergic to that, then it would be a big no-no in use. So we said that, well, look, in the processing, we are using such temperatures that anything would get burnt off. It will not remain in the packaging. So I think that was sufficient to convince the retailers and have this accepted. But the critical thing came was, and this is where Daniel was also involved, is to make sure that when you do pack this, you're storing this in chilling temperatures, and you're looking at keeping the pizza in uh, 0 to 4 degrees C, 8 degrees C for a number of days, and it should not go soggy and pulpy during that period. It should maintain its strength. So we had to work on the composition of this to make sure that the composition is right. It has the sufficient dry strength and mechanical strength. The mechanical strength was provided through the ribs that you see over here in the disc, and that was a very positive step. The final consideration came was, well, when you cook the pizzas and take them out, or when it comes out of the packaging and when the customer opens it, there should not be any taint, or there should be no smell. Polystyrene, you see, is inert material, and that way it will not smell. Straw being what it is, it will have a natural taint. And in our processing, we had to overcome that this taint is also removed. So having done that, we came and we were able to match almost very closely the polystyrene price, because the volumes were very high. Now, it illustrates a journey that we had to take, and this is in the absence of some standards, some not so standards, etc. Then the last thing that we had to prove was to prove the life cycle carbon emissions are not higher than polystyrene and paper. Now, we did a carbon footprint analysis, and we found that if we are manufacturing closer to the location of use, obviously the transport related carbon emissions were very low. The raw materials processing and converting to product carbon emissions were not an issue. The only issue was if we were manufacturing this overseas, where rice straw is abundant and product is made there and then transported to a Western country, the sea freight and that emissions were higher. So those emissions were considered, and but the overall carbon footprint was much lower. So on other categories, we were substantially lower. It is only the transport that was higher. And that way we were able to convince the customer that it is a good solution. We've since gone on to develop packaging for fresh produce. And this is another product which we have got, which is a standard punnet, and it is used for fresh produce. It can be used for tomatoes. It can be used for soft fruit like strawberries and berry fruit, blackberries, etc. It can be top sealed with a film, and at the end of it, it is biodegradable and compostable. This product is now being sold in Canada, and the Canadian market, which is currently importing a lot of the plastic containers from China, are very keen on using this. Now, this is made again from biomass, and the Valiform's technology or recipe is in the composition of it and the molding parameters for this, etc. There are a lot of people now who are trying different materials and different combinations, because one thing is happening generally is newsprint and newspaper, which was being previously used for pulp molding as such, which is what we use as a conversion process, is becoming less and less. People are not buying as many newspapers as they do in the past because of electronic and digital print. So prices are rising. There are issues of processing also with that. Transportation is also there. So I think we're in a sweet spot as far as that is concerned. I think it's not limited to just post-harvest cereal straws. I think that we don't derive too much from nature. Nature, the trees are bioreactors. It doesn't leave any waste. It takes air, water. It grows. It gives you fruit. It doesn't leave any waste. We don't study the natural processes closely. So I think there are many other natural resources, surplus materials that we could use and learn from and utilize in converting to short duration, short life cycle products. And that has been our theme. And based on that, we have looked at other crops now. We're looking at grasses such as switchgrass and miscanthus, stem grass also. And we've been developing different recipes to fulfill packaging requirements. Now, surface texturing of these is another area that we're working on. And I think in fullness of time, we will, after addressing the fresh produce and what you call horticultural market, we will start addressing the chilled food market as well, because there the barrier properties and life cycle requirements are different. I don't think I have much to say other than that at this stage, unless there are any questions. Over to you. Thank you.